Okay, exercise 8.2, question number 3. If there are three parallel lines and the intercepts made by them on a transversal are equal in length, prove that the intercepts on any other transversal are also equal in length. So here we have three parallel lines, that is L parallel to M parallel to N. And here I have two transversal, P and Q, intersecting the lines at A, B and C for P, and Q intersect at D, E and F. And it says intercept on one transversal are equal. So let's say AB equal to BC. When we say intercept, it is this portion of the line, portion of the transversal which lies between the parallel lines. So here intercept AB equal to BC on the transversal AB, on the transversal P by L, M and N. Let's write the given. L, M and N are three parallel lines P and Q are transversal such that intercepts on the transversal P are equal. That is, as we said, AB equal to BC here. AB equal to BC. Let us write the to prove. To prove will be the intercept on the other transversal also should be equal. Let us prove that these intercepts are also equal. Let us remember that we have to prove this with the red marking. That is DE equal to EF. To prove this, let us make a little bit of construction. I'll draw a line through E, and that will be parallel to the transversal P, touching L at G and N at H. So that is our construction. Let us remember that GH is parallel to transversal P. So let's say a line GH parallel to P is drawn through E, meeting L and N at G and H respectively. Now let us prove. First of all, as the question says, L is parallel to M. By given, we can say that AG will be parallel to BE because they lies on the same line. AG parallel to BE, and also we can say that GE will be parallel to AB. The reason is by construction GH parallel to P. So from these two we can say that if AG parallel to BE and GE parallel to AB, AGEB is a parallelogram. AGEB is a parallelogram. So in parallelogram, opposite sides are equal as well. Let us write that GE equal to AB. I'll call that equation 1. Also BE will be equal to CH because BE will be parallel to CH because M parallel to N. BE is parallel to CH and EH parallel to BC. EH parallel to BC. Therefore, once again, BEHC is a parallelogram. So if BHC is a parallelogram, opposite sides will be equal once again. That is EH equal to BC. I'll call it equation 2. Now, from equation 1 and 2, let us write what we have both together. GE equal to AB is what we have in equation 1, and EH equal to BC. But according to the given, AB is equal to BC. AB equal to BC. This is given. Now if AB equal to BC, here we have AB equal to BC, again equal to GE. Just write them together, and BC equal to EH. Let's call this equation 3. Now let us prove that these two triangles are congruent because I need these two sides equal. Now in the triangles GED and HEF, first I'll be going for these angles, vertically opposite angles. That is angle GED equal to angle HEF. The reason is vertically opposite angles, and these two will be equal. GE equal to EH from equation 3. GE equal to EH from equation 3. Lastly, these two angles will be equal because they are alternate angles where L and N are parallel. That means angle DGE will be equal to FHE. Angle DGE equal to angle FHE. I'll just call it alternate angles where L parallel to N. Therefore, by, let's see what congruency will this be. I've taken this angle, this side, and this angle. So by ASA congruency, triangle GED is congruent to triangle HEF. Now, if these two triangles GED and triangle HEF are congruent, DE should be equal to EF. DE should be equal to EF. Hence, proof. Now, to explain more, let us remember that if there are any three parallel lines and the intercept on one transversal are equal, we have to just know that the intercept made on the other transversal also should be equal.